Welcome to our online classes. Today we want to talk about pressure in solids. We want to see some of the calculations that are involved in this area. And the first part, we said that pressure is the force acting normally or perpendicularly per unit area. So we want to see when pressure is acting. And from the formulation of this definition, we have the formula of pressure being pressure is equal to force, which is the weight of the solid, divided by the area of contact. We can also look at different situations where the pressure exerted is minimum and when pressure exerted is maximum. From our previous lesson, we gave two factors which affect pressure in solids. And the first factor was the area in contact, and in our today's calculations that factor is going to play a role because we are going to look at the surface in which the solid is resting. To start with, we talk about maximum pressure. Maximum pressure is experienced when the area in contact is minimum. Therefore, we have our formula being weight of solid divided by the minimum area. Then, if we talk about minimum pressure, pressure is minimum when the area in contact is maximum. Therefore, our formula becomes weight of the solid, we divide by the maximum area. Now, from that part, having gone through these formulas, we want now to look at an example which can give us the clear picture of how these formulas can be used. So, um, that takes us to now the next part, whereby we are going to look at those calculations. Now, let us start with the first example. Um, a block of soapstone of dimension 4 meters by 2 meters by 3 meters is 48 kilograms and is made to rest on a smooth horizontal surface. So you can have that picture of that block, that is a cuboid, that block. So it is resting on a smooth horizontal surface. So we are expected first of all to calculate the minimum pressure it exerts on the surface, and then we also calculate the maximum pressure it will exert on the surface. So looking at these dimensions, this block has 6 faces, of which 2 sides are identical or are the same. So we want to consider 3 faces which are going to be critical in this calculation. We have the face made up by 4 and 2 length and width. Then we have the face made by the length and height 4 times 3. We also have the face made by the width and the height 3 by 2. So in that case, we are going to experience different areas that are in contact. So in that case, the first question is asking us to calculate the minimum pressure it exerts. So we said under minimum pressure, we are going to look at our formula as the weight of the object divided by the maximum area. So in this question, we have been given mass, which is 48 kilograms. We can change the mass to kilogram to weight or force, which is W is equal to mg to give us 48 times 10. So we are going to get 480 newtons. Then what is the maximum area? From the dimensions given here, we have 4 meters by 2 meters by 4 meters, this one by 2 meters by 3 meters. Which two dimensions here, if we multiply them, they'll give us the least or the minimum area. And remember, all these units must be in the SI unit of length, which is the meter. So if they were in centimeters, our first task was to convert these units to meters. And if these kilograms were in grams, our first task was to convert them to kilograms. So we have 2 times 3 will give us 6. Unlike 4 times 2, which is 8, and 4 times 3, which is 12. So we take the minimum area. Here is 2 times 3. If we are talking about the minimum pressure, so we want to talk about maximum area. So from these three measurements here, we have these 4 here, as you can see, the 4 and 3 will give us 12, which is the greatest area. So that is the maximum area that will be in contact. So in our working, we have already said weight, which is 48 times 10, divided by the maximum area, which is 4 times 3. So this one gives us 480 divided by 12 to give us 40 newtons per square meter. Now, what if the question is asking us to determine the maximum pressure? Maximum pressure is determined by the weight or the force of the solid block divided by the minimum area. Still, we can go back to that question and we check from the dimensions given of this block, which two dimensions, if we multiply them in their SI units form, can give us the minimum value. 4 and 2, that is 8. 4 and 3, 12. But 2 and 3 will give us 6. 6 is the minimum. So we take 2 times 3 as the dimensions of the minimum area. So that one in our working, remember the weight is the same, 48 times 10, which is for 80, divided by the minimum area, that is 2 times 6, which times 3, which is 6, to give us 480 divided by 6. When you divide by the 2, you are able to get the maximum pressure, which is 80 newtons per square meters. So that is all about that first question. And for our students, I want you to always remember that in this topic or in any other topic, let us always work out these questions with all our dimensions in their SI unit set. Then we have another question here. An object whose area of contact with the floor is 5 square meters exerts a pressure of 900 pascals. Then we are supposed to calculate its mass. So looking at this question, it's talking about an object whose area of contact. So it has given us the area of contact and it has given us pressure. So what comes into our minds first of all is the definition of the word pressure. We say pressure is the force acting normally per unit area. So in this case, once we formulate this definition, we know pressure is equal to force over area. So in that case, first of all, we are going to look for force in this question before we get to mass. So we are going to say force from the formula pressure is equal to force over area. We can now make force the subject such that we have force is equal to pressure times area. So the pressure from the question is 900 pascals and the area is 5 square meters. So pressure times area, that one now is 900 times 5 to give us 4,500 newtons. Now once we have that force, which is a weight, then we can say W is equal to mg. Weight is equal to mass times g. In that case, we make m the subject of the formula and we have mass is equal to weight over g. In that case, our weight is 4,500, that's 4,500 newtons, over the g, which is a constant, 10 newtons per kilogram. In this case, if we simplify that, we are going to get 450 kilograms. Very simple question there. Then moving on, we have another question here. Another question that has been, this question reads, a block of copper of density 9 grams per cubic centimeters measures 5 centimeters by 3 centimeters by 2 centimeters. Given that the G is 10 newtons per kilogram, determine. So look at the block there. We have the block of measurements 5 centimeters by 3 by 2. Then we are supposed to determine the maximum pressure. So in this question here, the examiner, or the concept that is being tested, we want to see whether the student is able to relate on concepts of determining mass. So now, obviously, when we're determining pressure, the formula for determining pressure is force over area, and in this case we are required to find the maximum pressure. So it means that we are going to get the weight of this particular object divided by the minimum area to give us the maximum pressure. But for us to get this weight, we must be able, first of all, to calculate the mass, then times g. And from the question that we've been given here, for us to find the mass is equal to density times volume. So from this question, we have already been given what density is. Density is 9 grams per cubic centimeters, and we have the measurement here, which are going to help us get the volume. So in that case, we are having rho Vg. Rho V is a density, V is volume, then G is gravitational pull. So first of all, we change the 9 grams per cubic centimeters into kilograms per cubic meters into kilograms per cubic meter. So we multiply by 1000, we get 9000 kilograms per cubic meters. Then now, how do we find the volume? Volume is length times width times height. So we convert all those units to meters. So 5 centimeters be converted to meters. We get 0.05 times 0.03 times 0.02. So those will give us a volume which is 30 times 10 power negative 6 cubic meters. That is in standard form, or we can just take it the next value, then times G, then times G, then we divide by the minimum area. What is the minimum area in this case? Minimum area is the face that will give us the least area, and from our diagram here you can see it's 2 times 3, which will give us the minimum area, not this other one. So it is 0.03 times 0.02 in SI units, that's the meter. So we are having 6 times 10 power negative 4 square meters. That is the area, that is the minimum area in the SI unit of area. So when you work out all this, we are going to get 4500 newtons per square meter. Then the next question, they are asking us of the minimum pressure. Already, once you get the word minimum pressure, your formula becomes weight over the maximum area. Already we know the weight from our previous calculation in part A. Our weight is 2.7 newtons, courtesy of the density times volume times G. It gives us 2.7 newtons. Then now, going back to that diagram, which face will give us the maximum area? Is the face of dimensions 5 and 3. This face is a very big one. This one here, it's the maximum area. So it's 0.05 times 0.03. So going to give us 0.0015 square meters. When you divide that one, we are getting 1800 newtons per square meter. That is now the minimum pressure in this question.